died out on me last time too, right? Okay, we're back, and yeah, we're getting there. So now our Husky CT has module 1, a syllabus, link to kind of my main website so you can get to like other learning materials, and then also schedule office hours and those kind of things. So I'm just starting off with like everybody's favorite, like logistical stuff. Everyone loves to like hear the bureaucracy of their education because it makes it more fun if you have boxes to check. Yeah. So we'll start off there. So we have website, syllabus is here now. Let's open new tab. And kind of coming down here. So there is a textbook that library provides. I'll zoom in a little bit. And we had taken a look at this quickly last time. I like this textbook because it focuses a lot on like how do you go from an idea of like this is an engineering problem to here's an equation that I can solve and actually start doing some work. So that's what I like about the textbook. There's a whole bunch of other content in this website, and I've been kind of changing it a little bit all day today to try to get it ready for our spring 26 semester. And I think we're in good shape. We're getting there. So now, get in here. Let's look at course requirements. This is what I have so far for what I think are some great deliverables so that you can practice doing some dynamics and get credit for the work and learning that we're doing. Participation, that one usually, so what I do for that one is at the end of the semester, I'll send you a form that asks you to assess your own participation in the class. So it asks like, who were you interacting with? Why, like, what did you learn? What did you struggle with? So give you a chance to have like a small control over your grade and how you get credit for that work that you're putting into the class. So that one's participation. Stop, I'm pausing for a second. Questions on that? I'm stating there are questions on that. And I'm wondering, what are the questions on that? Yeah. There are questions. That makes total sense. You've seen this a million times and you know exactly what to do. No, it's brand new. But you're okay. You're like, this guy seems like he's on it, and I totally trust him. That's it? Nailed it? Poor young fools. Okay, anyway. So next thing is reading quizzes. So I did some prompt engineering, gave it our course website as a reference, and told it to either act as like a teaching coach or a quizzing coach. And so you can go in and have it do either or, like teach you about something or test you. And next week I can show you kind of how that works. But it's kind of a neat way to like interact with the material. And the nice part is it generates a quiz on the fly. And I'm not looking for like make sure you get all the right answers. It's more like how do you engage with this, and what kind of questions do you have? Are you pushing it to like push you a little harder? Are you saying like keep it simple? And it's an AI, so it is designed to keep you engaged. The longer you use it, the more money they make. So I don't know, take that with a grain of salt. I don't love like telling companies, like big AI companies, to like build bigger servers so that my students don't have to read anything. But it is kind of a cool tool, and it helps out. So that'll be like 10% of the grade is having like module 1, 2, 3, 4, 4 reading quizzes, like 2.5% each. There are questions on this, just like the last one. What are the questions? Yeah.
How many times do you get per
Quiz it as many times as you want. So this is one of my grading 67 times. Yeah, 67 times. This is something that I like to do in my classes. You turn in an assignment, get some feedback. Let's say you got an 80 on the reading quiz because AI told you you got a C. The TA thought you should have a B. And you're like, well, I get this now. Let me redo it. You can resubmit it, show that you got an A. TA agrees, yes, you have an A, and totally fine. And it's unlimited submissions. Yeah.
So we don't have homework other than that and projects that kind of do like class.
And then, so the next thing, so as far as like homework, oh my god, it crashed again. Did it? No. Maybe? I think it did. Chrome is struggling today. It doesn't like, maybe I have too many tabs open on this other one. I'll close this other one. I don't need it. Okay, so the reading quizzes, that one's kind of like on your own time. You can do that. We'll go through it to show like how, kind of the mechanics of how to do it, or I can like post something online about how to do it. That might work better rather than using class time for it. Then the case problems, what we'll do is each week, every other week, we'll have like a new problem that we're working on in class. And so my solution to increase class size, reduced support for increased class size is that we're gonna do like group project submissions. I'm waiting for people to be like, no, but it's okay. Okay, all right, so we'll work on group project, yeah.
What will group sizes be?
Group sizes are 4 or 5 is the main thing. If you are the kind of person that like has to work alone, like it's okay if your group is like 2, but 4 or 5 is ideal for us for the semester. And oh, sorry, yeah. The group gets A grade. Yeah. But it's the same thing. So if your group gets an 80, then you can resubmit the work and get the points back based on feedback. So it's not set in, nothing in this course is set in stone. Like if you turn it in, you get a C, that's not with you forever. You can look at the feedback, figure out how to improve it, and that's the main thing that I'm looking for is like, what are you, at least in the resubmission, not so much like fighting with the logistics of like, well, you said to calculate X and I calculated a different X from another problem, so I should get the points back. It's like, well, yeah, there's miscommunication all the time, but you have an engineering problem, you gotta deal with people during this engineering process. I know, it's the worst, people. Oh man. But people are part of the engineering process. So meeting TA and my expectations for that, part of that's communication. So you'll get some feedback. If it's not to the level that you want, then resubmit and get those points back. Yeah.
The group's random?
The groups are not random. So what I want, so the groups we're gonna try this week. So we'll try an assignment about like the philosophy of dynamics. We'll do that. We'll start it today, and then we'll see how picking groups works. because I said create 50 groups and then have people self-enroll. Have you tried this before? Does it work? It works? All right. You ready for it? Can we do it? Okay. So what we'll do is, and it works best if you work with people in class and then enroll together in the same groups and then submit the assignment that way. Would that make sense? So that would be like meeting in class, building the groups, getting work done, and then if you can't make it to class, like connecting to people to help finish these little like case problems outside of class. No issues? This guy's on it, this professor. It's like, oh yeah, smooth sailing. Everything's gonna be like even keeled, nice wind, nice tailwind. Actually really like a nice like bow reach would be a great like sailing, relaxing, smooth seas. All right, so that'll be case problems. Roughly 7 of them, like every other week. Maybe it'll be 8, I don't know, we'll figure it out. Depends on how long it takes us to work through problems, but we'll talk about them in class, figure out initial thoughts, problem solving approaches, how to actually like finalize solutions. And then the last part is our projects. So there are 3 projects that are Jupyter notebooks with Python code. I'm not expecting you to become like experts in coding. It's not a coding class, we're just using coding, we're using Python code to help us explore some physics problems. So that'll be those 3 of those notebooks and then 3 of those projects. Then the last project is another group project where it's like independent research. It's not a master's thesis, it's not supposed to like change the world, it's more of just applying dynamics to some kind of problem, whether it's like linkage design for formula SAE or like biomechanics of prosthetic knees, like anything like that. You gotta look up what are the parameters that you need, what are the constraints on motion, what kind of forces are you, bless you, and those kind of things. That'll be like the last project and the first project. First project is also like picking a group and deciding what you want to do, and then throwing it all out and starting over for project 5. Questions now? You ready? Or actually, should we look at, let's just try it, right? There's nothing better than just like doing it. Learn by doing. Let's do something. Because there's stuff. I don't want to keep describing everything. So we have our first assignment, philosophy of dynamics. That's okay. Oh, join a group to participate. All right, so I can't join a group. That's okay. All right, so there is like an inherent assumption in Newton's laws of physics that it's a philosophical assumption. It's not an engineering thing. It's not something that you can like observe and say like, yes, this is true or false. What are the 3 laws in Newton's mechanics? Do you remember those? Or any law? Do you know any law? Anybody? You can even shout it out. No need for any law. F equals ma. So let's start with that one, right? So really, an applied force changes momentum. It's the only way to change momentum. that force is always proportional to changing momentum, or force is mass times acceleration. What's any other law? We need two more. Yeah. Every action has some equal opposite reaction. And I'm putting them in order. Every action or force has equal and opposite reaction. Did you have the last one?
Yes, an object at rest remains at rest unless acted on.
Okay, yeah, so only way to get motion, so rest, at rest, motion, in motion, unless force, action. So unless you have an action, you can't change anything. And action's always governed by this equation, F is always ma. But every action is coming from some other equal opposite reaction. No one disagrees? You can disagree with Newton. Plenty of people have tried. And usually, sometimes it's cool, sometimes it's good debates. But no initial gut, like, no, that can't be right. It's too ingrained at this point. It's like you have dreams about this, nightmares. Okay. If this is true, so if every action is some reaction and there's always some governing F equals ma, do you have free choices? Like, can you make a choice? Or is every choice due to some action reaction? Like, is it all cause and effect? Or can you actually make free choices? So what I want you to do, since this is now group project sort of work, talk to people next to you. What's your initial feeling? Do we have free will, or do we only live in a Newtonian world of action-reaction? So that's what we're trying to figure out today. And I'm sure we'll solve it. So, in asking this question, a couple other questions came up of, are your choices and your emotions governed by physics? Like, can you make a choice outside of, like, the laws of physics? What do we think? So let's try answering. Those two are yes or no questions. So we'll take a poll. Choices are governed by physics. We'll say yes versus no. So who says choices are governed by physics? Maybe 3/4, maybe 2/3, something like that. See, oh, maybe more. More? Okay. I'll give it 75%. Who says no, choices are not governed by physics? Some, two, and then the rest refuse to answer. It's okay. Maybe like only like 5%. So we're missing, or maybe I missed some of the votes. What about emotions? Yes, governed by physics. Are emotions governed by physics? Do we think, is it the same kind of group, roughly? Maybe? Okay. What about emotions? No, not governed by physics. More people say emotions are emotions not choices? Maybe like 20, I'd give this one 25%, and this one more like 60%. Yeah, is this a philosophy class? What class did we sign up for? What are we supposed to be here for?
As long as I get my credit.
Just need those credits, yeah. Get those credits. So let's say all this stuff is governed by physics, at least if we say majority rules. Can you have free will if everything about you is governed by physics? Yes. Some still say yes, right? All right, so why? Where do you get the free will if everything about you is trapped in Newton's cause and effect world? We'll start up front.
You would still have the ability to use free will within the constraints of physics. You still have free will to do whatever as long as you're within.
So it's constrained. Constrained, not controlled. Okay. What else? Yeah.
Usually like choose how you react to the physics.
So you can make a choice.
Choices that like you're gonna have to like no matter what you're gonna have to make the choice. Because like it's kind of how it happens, but you get to kind of choose.
Okay. And the choice is not. So I guess you're kind of.
Free will part.
So choice is, you're in the no camp on like choice can be outside physics.
Oh no, it's like still part of physics.
Oh, it's still part of physics.
Yeah,
Oh.
because like you're still forced to make that choice.
Okay, but you're forced to, and then I'll come back and then, yeah.
I think there's a lot about physics that's still like in the realm of like uncertainty. Cause like there's a lot of stuff that like, there's the whole thing of, you know, like Schrodinger's box where we don't actually
Yeah.
know which outcome is yet. So it's like, you can say deterministic, but it's deterministic based on a lot of variables that we don't know. So it's basically chaotic anyways.
Okay, is a chaotic system not part of cause and effect? Does that,
Like, cause you can say it's from
What do we-
cause and effect, but if the cause isn't known, then it's kind of hard to really determine what the effect is either.
yeah? Let's see if I still have it. All right, so here it's very much like a Newton simulation. It'll catch up in a second. Very much like every time step is following Newton's laws of cause and effect, and I have 100 different pendulums that are all just slightly different, like imperceptibly different, and then as time goes on, they all choose a different path. You could say they choose, but every second along the way, they're always, F is always MA. So there's always that cause and effect. Yeah.
I think that you can also kind of relate it to like quantum mechanics, where there's a lot more probability of like a double split,
Okay.
entanglement and stuff like that. So a lot of free will, I think, is seen as ambiguity. So we think it's free will, but I do still think we have free will.
Okay.
And with like one of Newton's laws, where it's equal and opposite, that doesn't mean it always happens to be one thing. It can be distributed. So as long as it adds up to that, there's a lot of ways you can get to that equal opposite reaction.
Okay. Yeah. So you could, like something exploding. It can explode in a lot of different ways, but at the end of the day, it still satisfies, like, it started with 0 momentum, it ends with sum total 0 momentum. But maybe there's like choice in how it exploded, some sort of thing. Yeah.
Forgive me if I'm presenting a false dichotomy, but like there are really only two choices, right?
Okay.
Things could be deterministic and
Yes.
they happen the same way every time when you make a decision, right? You make a decision as a human being.
Okay.
Or they could be random. Neither of those is really true.
Okay.
There's a
So.
situation in which it's based on nothing. It's either based on something random happening, like quantum mechanically, or it's based on something normal and deterministic at a macro scale happening. But I don't see any third choice.
There's no third. Yeah, there's no room for free will. It's either random or predetermined, kind of. And free will is just sort of this.
You could argue it's not predetermined, but that still doesn't make it free, as far as I'm concerned. Like
Mm.
coin flips doesn't have to be free. You know what I mean?
Yeah. So coin flip is a typical example of like, yes, whether it lands on heads or tails, we can empirically measure that it is random. Like there's no way to predict beforehand that it's gonna land on heads. I mean, you can make the case like if you knew everything, and this was kind of in Newton's day, and so I bring this up because in Newton's day the idea was if you could measure the position and motion of every particle in the universe, then you could just predict everything that will ever happen. Like nothing is outside of you. You become this like omnipotent thing because you can build this model and you know exactly what's going to happen. And people still follow that belief, whether or not they like kind of truly believe it. They still like that's still like the basics of physics. It's looking for the Big Bang, looking for that time zero of like what happened before the universe expanded. Like a lot of that is like, oh, if we just knew everything at one point in time, then there's no room for free will anymore. We solved it. We're done. Put a check mark in the book, and we don't need to do anything else. So that's why I'm bringing this up. It's like it's definitely. Okay. What about the? Oh, yeah. Go ahead.
I'm just gonna speak back onto the point you made earlier with
For the dichotomy.
happens at random, or like with the example of the coin flip. I want to say that the choice is the free will. That what if you don't flip the coin down? Like it can be either like how I see it is it could always be heads, or it can be a random chance. That's how I like interpret that.
Yeah.
What if you never flip the coin? What if like you melt down? Now there is a coin.
Okay.
I think it plays into the fact of like consciousness and like something being alive, because there's always going to be a cause and effect if you like drop a pen. Then, but what about the choice to pick up that pen? That will then create a cause and effect. You need that like choice. For
Okay.
the cause and effect to happen.
Okay. So there's something. It feels like the intuition is sort of that we're doing stuff that's not just kinematic equations. Like, I don't get to class through a parabolic arc. I walked here, and I stopped, and I picked up some garbage, and I put it in the trash can. So I'm like, this is gross. Like, and none of that garbage didn't follow a parabolic arc from somewhere else to get into the garbage can. It missed the first round, second round. Got it. So yeah, maybe there is something else. Yeah.
Forgive me speaking again, but
No, drop some more, do a false dichotomy. Love it. Or a straw man argument, or any kind of, yeah, anything else?
yeah, so I just wanted to say, like, I guess I was using the coin more as like a metaphor, right? Like, even an example is like, what if you don't pick up the coin? So the coin was more of a metaphor for what's happening in the synapses of the brain. Like,
Okay.
those are all particles that act by quantum mechanical and Newtonian physics, right?
Yeah.
If you observe every particle, it's not that they're all deterministic. Some of them are random, but in your brain it is either deterministic or random.
Okay.
There's no other way that particles act, at least in science, at least currently.
So this is also something, do you know what the limits of, like, when F equals ma fails? Like, when you can't say F equals ma? When can you not do it? Do you know? Yeah, so E is always mc squared. Yep, that's true. Yeah. So that one's always true whether or not F equals ma. Yeah.
Doesn't force break down a bit when you get to things like photons and massless particles?
Okay, yeah.
Like, because then you'll have to kind of refer to like momentum in terms of like the wavelength and the frequency of the photon, and then you can use that to sort of create momentum, even though it doesn't like, you can't really have force with like forces mass times acceleration.
Yeah, so we're lagging today, but it'll catch up in a second. So definitely mass of the particle has to be, the mass of the thing that you're dealing with has to be bigger than like subatomic. Protons, neutrons, they follow F equals ma. Like you can say, like, I applied a force to this proton, we moved this much, that was the acceleration, and it works perfectly fine. There's no issues with it. And especially like molecules, like if you think about like drug discovery, none of that is quantum mechanics. It's all classic F equals ma stuff of like springs and masses all connected to each other, even though it's like these molecules interacting. It does have to be a constant mass object, so when there's like radiation, so constant, like rocket science, Newton's laws apply just fine. Like, even though you have a changing mass, it's like, but you can't have like dissociation of mass, like into massless particles and then supermassive particles, things like that. Velocity has to be much less than speed of light. So when I say much less, like 90%, still pretty much okay. So you can accelerate things to about 90% the speed of light, and it's still F equals ma. And then you do need like kind of short time spans, like not millennia. It's hard to predict like how things move over millennia, and especially if they're super heavy. Like, what is a black hole doing in 6,000 years or like 6 million years? Like, starts to break down. You need like other relativity kind of theories involved there. But this still covers a lot. Like, this is everything in your brain. You don't have particles moving speed of light. They're moving fast, but not speed of light. And they're all like maybe electrons. Most of the time it's like molecules. Like, everything in our body, nothing's breaking the sound barrier when we do stuff, because otherwise you would hear like a sonic boom every time we had like an epiphany. Jaboof, like, yeah, it's things. So we're all like, we're tucked in there. We're nice and Newtonian. Still Newton's laws, no? Or disagree? Well, I think a lot faster than you, Professor Cooper. How are we doing on time? We got 5, is it 5? 2:15, okay, 5 minutes. Okay, so the last question. Who says we have free will? Like, we have to have it. We'll go for, like, percent. Still pretty high, even though we had a lot of discussion. I would put it somewhere around, like, 70%. Who says there is no free will, it's a Newtonian world, and we're just sort of, maybe we have illusions of free will or something, but more like 10%? Who has no idea? And yeah, 1, good. Only 1? Only 1 will admit that this was just more confusing, that they've left this whole discussion with less, yeah? 2%, right? 2, 5, I would, normally it's more like 50%, or like less certain that they have free will than before. But I'll put 5% somewhere in there so far, and some others that are somewhere along the way. Bring this up. One of the things that I think distinguishes like great engineers and great sort of like educated people is their ability to like think about what is the philosophy and like underlying assumptions of the things that they're using, of these tools. Newton's laws, it's a tool in your tool belt that will help you solve problems. Does it describe your daily life and can it predict your next choice? No, definitely not. Like it's not, and it's never even going to predict what people will do with products that you're building. Like you can have like a general sense of like, I think people will do this, but as soon as you assume that, there's gonna be people that use it in a completely different way, because it's hard to know. Okay, so last logistic thing that I wanted to bring up. Monday, crazy snowstorm coming. Let's just cancel class now rather than wait for Monday morning and stress about it. Stay safe, stay warm, take care of each other, and we'll be back on Wednesday. All right.
This might be a little off topic to what we were talking about,